Hi everyone. Today we're going to be doing our notes on 2.3, getting information from the graph of a function. I want to start off with this example. The function p of x is graphed below and it shows the percent charge of my laptop battery over a 24-hour period, where x equals 0 represents midnight, x equals 12 represents noon. 1a, let's go ahead and approximate p of 0, p of 9, p of 12, and p of 17. Let's start with p of 0. This is our y-intercept. So where x equals 0, we can see that the y-intercept all the way up here is approximately 85. For p of 9, so we're going to look at the x-axis and find x equals 9, and we're going to go up to the graph of the function. And I see it intersects like right about here or so. Now if I look to the left and look at where that y value is on the y-axis, so if I go straight left, it's approximately like 95 or so. Okay, let's go ahead and evaluate p of 12. So p of 12, I'm going to look at the x-axis and find x equals 12. This is right here. I'm going to go up, straight up to the graph of the function, and then find where it crosses right here. And then to the left, I'm going to see where that crosses the y-axis, and I see it's maybe about 75 or so. Your answer might be a little bit different if you approximated maybe like 77 or something close to that. And last but not least, p of 17. Let's go ahead and approximate that. So we're going to find 17, x equals 17 on the x-axis, and then we're going to go straight up to where it crosses the graph, and that's like maybe right about here or so. And then if I take a look all the way to the left, straight left, that's maybe between 60 and 70. We'll call that 65. And again, you might approximate maybe like 63, something like that. Okay, so now 1b, what is larger, p of 14 or p of 18? So in order to find that, we have to evaluate the function for both p of 14 and p of 18 and see which is greater. So we'll start with p of 14. Find 14 on the x-axis, go up to the graph, right about here, and then go to the left to see what that y value is. So straight to the left, I see is about 65. So I'm going to just go ahead and write that. P of 14 is approximately 65. Now p of 18, we're going to find 18 on the x-axis right here, and then go straight up to the graph of the function, and it's like right here or so. Yeah, about right there. And then straight left, we've got maybe, yeah, right around there, like 85 or so. So p of 18 is approximately 85. So then the greater of the two is the 85 or p of 18. Letter C. Approximate the values of x for which p of x is equal to 80. So remember, p of x is referring to those y values here on the graph. So I'm looking at where the y values are 80. So starting on my y-axis, I'm going to look at 80, and I'm going to go directly to the right and see where the function crosses. So it crosses right about here. Let me go ahead and mark that. And then it crosses in another spot. If we keep going right, it also crosses like right about here. So looking at those x values, I see that occurs. I'm going to just draw a line. It's a little bit easier for me to see. Yeah, right about there. And then I'll draw another line. Okay. So we've got maybe x is equal to, I'll stick with whole numbers. It looks like it's probably close to 11. And x is equal to 18. Okay. So what does this mean in the context of the problem? So we're looking at x values are 11 and 18, and then the y value is 80. Well, going back to the original problem, our x represents the time over a 24-hour period starting at midnight, and then our p of x represents the percent of the charge of the laptop battery. So what does this mean in the context of the problem? We can say that at 11 hours and at 18 hours, the battery is at 80% charge. Okay. Letter D, determine the maximum of the graph and at what x value it occurs. So looking back at this graph, the maximum is the highest point on the graph. So I can see that it occurs, we've got a flat line up here, and we've got a flat line up here. And that's at 100, 100. So the x values for which that occurs, if we look down, it starts at maybe 4 hours or so, and then goes until maybe 8 hours. And then it starts again at maybe 20 hours and goes until 24 hours. So the maximum value is a maximum of 100% at x equals, let's go ahead and write the interval. So we'll say from 4 to 8 hours. And we said 20 to 24 hours. So let's write that using interval notation. Okay. Determine the minimum of the graph and at what x value that occurs. So the minimum is the lowest point on the graph. I can see that, well, it goes up, and then it goes all the way down, and then it goes back up. The minimum is right here. And that's about, if I look to the left, that's about like maybe 50. And that occurs, if I look down, at 16 hours. So we have a minimum of 50% at x is equal to 16 hours. Letter F, determine the intervals that p of x is increasing. So as a reminder, an increasing interval is if for some x less than another x, the f of x, x1, we'll say that first x, is less than f of x2. So f1 of f of x1, there we go, f of x1 is less than f of x2 for some x1 less than x2. And then the function is decreasing, so this is for g, is decreasing if that f of x1 is greater than f of x2 for some, again, x1 less than x2. Okay? So we can also just look at this graph and just see, you can think for linear functions, you can think slope, but think of like where the function is increasing or growing or has a positive slope if it's linear. So I can see that this occurs between 0 and 4. So 4 was our maximum. So it's increasing, 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 hits our maximum, stays at a maximum. And then I also see that it increases from the minimum all the way back up to that maximum. So we're looking at the interval from 0 to 4 and from 16 to 20. Okay, so let's go ahead and write that. The intervals that p of x is increasing is from 0 to 4 and 16 to 20. Okay. We do not want to include these endpoints because at the ends, it's not increasing or decreasing. It's maxes and mins. Okay. For g, let's find where it decreases. So this is where it's going down. I notice this happening between maybe about 8, x equals 8 and x equals 16. So the interval using interval notation is parentheses 8, 16, parentheses. Okay, let's find the domain and range. So domain, these are the set of x values that can be plugged into the function. Well, the x values that are plugged in are from 0 to 24 inclusive. So let's go ahead and write that. From 0 to 24 inclusive. So those are our square brackets. And then the range, these are the y values that come out of the function. So the lowest y value is our minimum, and the greatest y value is our maximum. Well, we have a min of 50 and a max of 100. So then our range must be from 50 to 100 inclusive. Okay. Go ahead and flip the page. Example 2. Let's go ahead and graph this polynomial function here on our graphing calculator and find local mins, local max, and then what those mins and maxes are, and then the interval for which it's increasing and decreasing, and then also the intercepts. Okay, so go ahead and take out your graphing calculator, your Inspire. We're going to start a new document. I'm going to go to graph, and we'll type in the function. So the function is x cubed plus 3x squared minus 2x plus 1. So we have x cubed plus 3x squared. and then minus 2x and plus 1. So I hit enter. So I noticed that the whole graph doesn't quite fit on this display here, so I'm going to change the window size. I do that by hitting Menu, number 4, Window Zoom, and let's just zoom out a little bit. Let's see if we can get more of the graph. It's going to ask for a center, so it's going to ask what's the center about which you want to zoom out. And so I'm going to just click probably around the center of the graph of the function. So I zoomed out now, but now it looks really narrow. We can get a better picture of this graph. So I'm going to actually adjust the window size. So I'm going to hit Menu, again, Window Zoom, and I'll go to Window Settings. Now, I don't need all these x values from negative 21 to 18. I can just zoom in on the x values, say, from negative 5 to 5. And that should give us a good picture of the graph. The y values are pretty good. We've got those maxes and mins in the window. So I hit OK, and here's our graph here. Okay, so let's go back and see what we need. We need local minimums and maximums. Okay, so we have a local minimum. Well, let's start with, we'll start with minimums. So to do that, we're going to hit Menu, and we're going to go to Analyze Graph, number 6. Here we're going to click number 2, which is minimum. This is going to ask for a lower and upper bound, so the interval that contains the minimum. So I noticed that the minimum right here, this is the trough of our function. So I'm going to choose the lower bound to be left of the minimum and the upper bound to the right of the minimum. And I could do it just to the left and right of it and have a small interval, but I like to give myself a lot of room. So I'm going to choose values that absolutely contain the minimum. So there's my lower bound. I just clicked there, and then my upper bound to the right, I'm going to click there, and that's going to tell us the coordinates of the minimum. So we have 0.291, 0.697. So we have 0.291, 0.6697. There it is. So we have a minimum of 0.697 at x is equal to 0.291, I believe. Yeah. Okay. So here we can even write the minimum value is 0.697. The maximum is very similar. So on the graph, again, we'll go back to Menu. We'll go to Analyze Graph. But instead of choosing minimum, we'll choose number 3, maximum. It's going to ask us for a lower and upper bound. Choose points that are absolutely to the left and to the right of the maximum. So the coordinates for the maximum is negative 2.29, 9.3. So we have a max of 9.3 at x is equal to negative 2.29, I think it was. Yeah. All right, so our minimum value, or maximum value, excuse me, is 9.3. The interval for which it's increasing. So we'll start with increasing. So the interval for which it's increasing, well, I know that this is a cubic. This is a polynomial of degree 3. So it's going to start at negative infinity. It's going to increase until it hits the maximum. And then from the maximum to the minimum, it's going to decrease. And then onward past the minimum, it's going to increase off into infinity. So the intervals for which it's increasing, we've got 2 of them. We have this one on the left all the way up to the max, and we have this one to the right of the minimum. So the intervals is from negative infinity to the x-coordinate of the maximum, which is negative 2.29. We don't want to include either of those. Remember, we never include it for infinities. But then we also don't want to include it for the negative 2.29 because that's our maximum. So it's not increasing or decreasing. It's our maximum. It's also increasing from the x value of our minimum. So from 0.291, non-inclusive, to infinity. It just continues increasing forever. Decreasing. So looking at the graph, we know that it decreases between the maximum and the minimum. So the interval for which it decreases is non-inclusive. We have, not that one, negative 2.29 to 0.291, non-inclusive. Okay, last one here. So intercepts. Let's go ahead and go back to our graph. We're going to hit Menu, Analyze Graph again, and we want to find intercepts. So like, for example, the x-intercepts is a 0. So this is number 1. It's going to ask for a lower and upper bound, so we're going to choose values that are absolutely to the left and to the right of the x-intercepts. Well, this only has one x-intercept, and it's right over here. So I'm going to choose a point to the left and a point to the right. We have a 0 at negative 3.63. So we have x-intercept, just one of them, at negative 3.63. And then our y-intercept, now you could probably get this from the equation. The y-intercept is where x is equal to 0. We can see on the graph here, it crosses the y-axis at y equals 1. So, and we could also find that from our equation. That's our constant term. So our y-intercept is 0, 1. Okay. Last examples here. We have example 3, number 1. The graph of a function g is given. So let's find g of negative 2, g of 0, and g of 7. So g of negative 2, looking at the graph, we find where x is negative 2. Well, g of negative 2 is where the graph of the function is on the y-axis. So we see that that is equal to 4. G of 0, this is our y-intercept. So where does it cross the y-axis? We've got it up here. So we've got 4, 5, 6, 7. And finally, g of 7. So here we have 4, 5, 6, 7. So the y value there is 4. So g of 7 is equal to 4. Oops, here we go. The domain and range. So the domain, again, is the x values for this function. The domain is from negative 2 to 8. And we do want to include it because both of those endpoints are defined. So negative 2 to 8. And then the range. The range are the y values that the function hits. So the lowest point is like right around here, which is at y equals 2. And the maximum, which we found actually is the y-intercept, is at 7. So the range inclusive is going to be 2 to 7. Find the values of x for which g of x is equal to 4. So looking at this graph, what are all the y values for which g of x is 4? We've got 1 here at negative 2, 1 here at positive 2, and 1 here at 7. So we have x is equal to 2, negative 2, 2, and 7. Find the values of x for which g of x is greater than 4. So looking at this, well, we know that it is 4 at negative 2, 2, and 7. But the values for which it's greater, well, I know it's between negative 2 and 2. It goes up and then back down. So this whole chunk of the graph is above the line y equals 4. Likewise, over here from 7 to 8, it's also above 4. So the intervals for which g of x is greater than 4 is from, not inclusive. So negative 2 to 2 and from 7 to 8. Okay? Now note on these brackets, we don't want to include it for that first piece from negative 2 to 2 because at negative 2 and 2, it is equal to 4. And we want strictly greater than. The same thing for the 7 over here. At x equals 7, the function equals 4. And we don't want to include that. So everything after that, and then all the way up to 8. So 8 is the end of our domain. We do want to include that because that is greater than 4, g of 8. So the maximum and minimum values. We have a maximum. Again, that was our y-intercept, g of 0. So let's go ahead and write that. So we have a max of 7 at x equals 0. And then our minimum value is right about, it's a little hard to tell, maybe at like 4.5. Yeah, we'll approximate that. So we'll say 4.5, and the minimum is 2. So we have a minimum of 2 at x is equal to 4.5. We'll just approximate that. All right, last problem. Number 2, graphs of the functions f and g are given, where g is the blue line and f is the red line. Which is larger, f of 0 or g of 0? So these are these are y-intercepts. So which y-intercept is greater, the red or the blue? The answer is the red, which is f of 0. F of 0 is equal to 3, and g of 0 is equal to maybe about a half. Which is larger, f of negative 3 or g of negative 3? So looking at the functions, x equals negative 3, the greater of the two is the blue line. It's higher up. So we have g of negative 3 is greater. And finally, for which values of x is f of x equal to g of x? So these are where the functions are equal or where they cross. So the values for x that this occurs at is at -2. They cross right here. And at +2. They cross right here. So the values for x is equal to -2 and 2. Okay. So this was our 2-3 notes on getting information from the graph of a function. We're going to get a lot of practice on this, so we'll see you tomorrow. Goodbye, everyone.